Okay, I can tell there are some great conversations going on in the room right now. We'll continue those during the break, of course. But for now, I'm delighted to kick off the lightning literacy round. 4 vignettes from 5 highly talented people, 5 minutes each. And we're going to start with Dr. Joanna Christodoulou. She is Associate Professor and Director of MGH Institute's Brain, Mind and Education Lab. Her research tracks down brain and behavioral correlates of reading development, as well as the effects of reading interventions. And fun fact, well, first of all, impressive fact, she was had a Fulbright fellowship year studying reading in Europe. And while she was doing that, she volunteered at the Athens Olympics. Joanna.
Hi, everyone. I have 5 minutes to share with you what I think is so exciting from the research front. And I'm going to use my New York pace of talking, so I hope you don't mind that energy. So I want to say I'm humbled to join this community and to speak with you about dyslexia. Our goal in this presentation is to talk about it from the perspective that's often not recognized or thought about as often as other things. That is, we want to talk at this moment about the summer. It's coming up. We think of sprinklers, we think of leisure, we think of activities or ramping up on hobbies. Well, we spend a lot of time thinking about the academic year, and I want to put a spotlight on those months when we're not in school. When kids are not in school, they are doing activities with their families, they're doing activities with friends. They're not in a lockstep curriculum that's consistent across all students. In fact, the whole reason that we have summer vacation was a topic of equity. It used to be the case that children in urban settings were in school 11 or 12 months a year. Children in rural settings were in school only 5 to 6 months a year. So the summer vacation is already a time when people wanted to make opportunity consistent across students. And so many of us here are invested in helping all students succeed with all of their strengths and in spite of their challenges. So an interesting visual for you to take a look at. From the perspective of what we call socioeconomic status, which describes parents' education and current occupation, there's been a really important finding, which is during the school year, kids from lower or higher socioeconomic status have fairly lockstep progress in their trajectory. When you look at the summertime, there is a huge divide, and that's partly being driven by the kinds of opportunities and the kinds of activities that children engage in during the summer. Every summer, many families, teachers, and parents might tell you, summer slide, summer slump. I left my students off in June, and I see them in September, and they're not anywhere close to where I left them off. What's going on? What's going on is the amount and time spent on literacy activities may fall very low during the summertime, especially in contrast to the academic year. And for some kids, that has an impact that's disproportionately more. And that means every summer there's an accumulation of difference. And the important part here is not only that every summer there are differences driving different kinds of kids from different kinds of backgrounds, but that by high school, that summer difference accumulates and accounts for up to 80% of the achievement gap in reading. So if we spend so much time and energy toward understanding the progress during the academic year, for such an important time in children's lives, it's worth putting a spotlight on the summertime as well. So with that, I want to share one of our research studies. We called it the START study because it was Summertime Adventures in Reading and Teaching. And anyone who's done an acronym like mightily know how hard it is to come up with a good acronym. So we were slightly proud about that one. So this was an attempt to understand what happens in the summer when we immerse children who are at risk with their reading and give them enriched instruction in literacy. So we had a program where we invited children who are at-risk readers to join us for a very intensive program. 4 hours a day, 5 days a week for 6 weeks, which meant each child had about 100 hours of reading instruction with us during the summer at no cost. And they got small group instruction, 3 to 5. These kids showed something really fascinating to us. The first thing that we saw was, on average, despite 100 hours of instruction, we didn't see change. And that is a shock, because doing anything for 100 hours at a time should change. But here's why. Our intervention group is what you see on the slide right now. The next group you're going to see is the group that was randomly assigned to not get instruction. This suggests that our at-risk readers who are not engaged in some degree of literacy activities are falling behind. It gives us evidence and numbers to demonstrate the summer slump in our at-risk readers. The other thing to share is that this group taught us something else. Among the kids in our intervention group, if we broke out and looked at individual differences, which is what we care the most about, our group actually showed quite variable differences. Half our group showed huge gains, and half of our, again, intervention group showed decline. This tells us something else. We have effective instruction that's working differently for different kids, and we want to do a better job of figuring out for whom should we do what. This behavioral difference was not only apparent in our scores from reading, but also in the brain. We compared our groups who were in the intervention and those who were not, and we found no group differences. But when we look at children who benefited, their brains showed significant impact from the intervention itself. With that, I want to highlight a couple of key points. One, the summer gives us a huge opportunity to consider how to support readers who may struggle. Two, the summer may give us a chance to avoid summer loss, but also make gains where we want them. We also want to recognize that children benefit differently from different intervention programs, and our job as researchers is to do a better job of figuring out for whom should we do what. For next steps, you can talk to me afterwards, and we'll transition to our next talk. Thank you.
Okay, thank you so much, Joanna. So next up, we have Dr. Rachel Romeo. She's a postdoctoral fellow at MIT's McGovern Institute and Boston Children's Hospital also. She studies individual differences in neural and cognitive development, focusing on language development and the effects of early childhood environment. She ran the Boston Marathon in 2017 in memory of Martin Richard, and a fact of resilience, completed the race despite breaking her ankle near the beginning of the race. Okay. Rachel.
See, you just have to keep going, and then you can accomplish great things, although slowly sometimes. I'm so excited to come speak with you all today. So in my work, I really try to understand individual variation. That's a topic we've talked a lot about today. I really want to understand variation in brain and behavior. How is my brain different than your brain? Why is that? Why is my brain different than your brain? And what do we do about it? So I want to start by posing a few questions that underlie some of the research I'll present today. So first and foremost, do children's brains adapt to their early environments such that there might be differences in the actual neural circuitry that supports reading, and then also in the way that brains may learn to read? And then if there could be these differences in the way that brains adapt, does this mean that there might actually be different causes of reading difficulties so that one treatment may not fit all, not a one-size-fit-all solution? And finally, this leads me to my goal for my research. Can we harness neuroscience techniques to tailor our treatments and optimize individualized learning strategies? And one of the ways I approach these questions is by studying socioeconomic status, or SES. I'm excited that I don't even have to define this. Several other speakers have. So it's an index of a person's financial, educational, and social resources. And it's also one of the strongest predictors of reading outcomes. So this is a graph. It is of assessment scores, but I think it makes the point of that for the last 20 years and long before that as well, we've had a pretty stagnant achievement gap between wealthier and poorer students. And this is despite our best efforts, dramatic policy changes to try and close these gaps. We haven't done it yet. And I think what's important about this is that we actually have a paradox between this and our research. So although lower SES students are disproportionately struggling with reading, the vast majority of the science we have on reading, the reading brain, the learning brain, is on high SES, relatively homogeneous samples of students. And I think this is important because it means that we actually have little understanding of how the process of learning to read may or may not vary depending on children's different backgrounds. And if we understand this better, could it help us to close some of these achievement gaps? And so I want to quickly tell you about a couple of studies I've worked on with, in collaboration with Dr. Christodoulou and Dr. Gabrielli here. So this is actually following from the study that Joanna just told you about, when we were trying to predict who would respond best to reading intervention. She showed you that we have about half of participants showing improvement, half not, based on the same instruction. And what we found is that the only factor that predicted treatment outcomes was SES, but in the opposite manner of what we expected. So actually here, the lowest SES student showed the greatest improvement in reading after we accounted for their initial disparities. And then this reading growth was commensurate with changes in neuroplasticity. So these regions in blue indicate places in the brain where lower SES students actually exhibited greater physical cortical growth in just 6 weeks after 6 weeks of reading instruction. So we see some of these canonical reading regions in the left hemisphere, as well as some compensatory regions in the right hemisphere. And of course, the question is why? Why are we seeing these differences? And one possibility I'd want to pose is that maybe there isn't actually the same underlying process going on. These children are all struggling to read, but perhaps for different reasons. Perhaps differences in their early life experiences are giving rise to different etiologies of their reading struggles. And so this is the basis of one of our current explorations. When a child struggles to read, there may be a number of underlying difficulties. One that's received a ton of research and that we've talked about today is phonological skills, or the knowledge of how the sounds of speech combine to form words. But another aspect that many children struggle with is about the text itself, an orthographic skill. So the ability perhaps to rapidly recognize and name symbols like letters, which is important for fluent reading. And we've just finished collecting data on a very large sample of children who both struggle and don't struggle with reading. And this is brand new results, so I'm excited to share them with you today. What we're finding is a difference between the deficits seen between higher and lower SES students. So in higher SES students, we're seeing that reading struggle is most strongly predicted by phonological skills, but it's the opposite for lower SES children. They may have the same diagnosis, but their difficulty seems to be more strongly predicted by orthographic skills. And so I think this may change the way we think about the neural systems that both support reading struggles, but also successful reading. And I think this leaves us with an exciting advance for our science. Perhaps a new direction for educational neuroscience is how we can employ neuroimaging techniques to be able to identify what type of instruction might be the best fit for each child, each individual child and each individual brain. And if we do that, might we be able to meaningfully chip away at these achievement gaps? So thank you.